we are going to see a problem on a projection of plane which is based on hexagonal lamina. Here the question is, a hexagonal lamina of side 25 mm is resting in VP on one of its corner. Draw its projections if the diagonal passing through that corner makes an angle of 30 degree with VP. So I'll explain the condition by drawing the XY line and locating VP HP. So let us get started. Now it is given in the question hexagonal lamina. Lamina is the other word for plane of side 25 mm. So a hexagonal plane of 25 mm side is resting in VP on one of its corner. So if it is resting on one corner, it means the entire hexagon is there in VP, and since it is given on one of its corner, it means that corner should be taken on left hand side, because for planes the left hand side is the reference for us. So I'll draw the hexagon here in VP. Of 25 mm side. For that, I'll take a radius of 25 mm in order to draw the hexagon. Drawing a light circle. Next, since the corner is in VP, I'll keep this corner, giving it the notation as A dash, because left hand side is the reference in case of planes. Next, from the same corner, I'll draw two arcs cutting the circle. Joining all these points in the proper sequence. So this is the hexagonal lamina. I'll give the remaining notations here. That is B dash, C dash, D, E and F. Now when this hexagonal lamina is seen from the front, it looks like a hexagon, but when we see it from top, it will look like a straight line, because in case of planes the thickness are negligible, so it will appear as a line. So projecting that line onto XY, after projecting all these points, I'll give them the notation here. This is point A. B dash, F dash are onto the same location, so this is B comma F. Next C comma E, and at last point D. So here is the hexagonal plane looking like a line in the top view. Next I'll make it dark. And making this hexagonal plane also dark in the front view. So this is the hexagonal plane. Now the question is, draw its projections if the diagonal passing through that corner, which corner on which it is resting, that is A dash. So the diagonal passing through it is A dash D dash. Now this diagonal makes an angle of 30 degree with VP. So 30 degree with VP will be seen in HP, and that diagonal A dash D dash, in the top view it is AD. So I'll make this line inclined at 30 degree. So selecting a point here. Drawing a line inclined at 30 degree as it is given. It is tilted by this point A. So I'll measure the length of this cutting plane from A to D. cutting an arc. Now this will give me the point D. Next, BF and CE. For that, I'll measure the distance from A to CE. For B and F, next I'll project these points in the VP, that is for the front view. So A and A dash, where they intersect, that will give me the point A dash. Next, for B and F, here where point B and B dash they intersect, that will give me the point B dash. On this same line there is point F as well, so I'll project F dash. For C and E, projecting C dash. So where C dash and C they intersect, that will give me the point C dash. Next, for point D, and here is D dash. Next, point E and E dash, where they intersect, that will give me the point E dash. Joining them in proper sequence. A dash to B dash, C to B to C, C to D, and in order. Then making all these lines dark. So this is the front view, here is the top view of the plane looking like a line, and since it is inclined, here the shape has slightly changed. So at first it was a true shape, and now it has become an apparent shape. At last, giving the dimensions, 25 mm side. And as mentioned in the question, we have completed the hexagonal lamina as per the given conditions, and with this we complete the problem.